Section 7.5 is about graphing f of x equals a times x minus h quantity squared plus k. And it begins by analyzing the graph of the quadratic functions of the type f of x equals ax squared. And then label the vertex in the line of symmetry. Then we graph functions of the type f of x equals a times x minus h quantity squared, and then label the vertex in the line of symmetry. And then lastly, the third objective is to graph functions of the type f of x equals a times x minus h quantity squared plus k. And again, finding the vertex, the line of symmetry, and the maximum or minimum value of the function. We begin this consideration by looking at f of x equals x squared. And so we select some values of x for x, and then compute the corresponding function value. F of x equals x squared, so minus 3 squared is 9, minus 2 squared equals 4, etc. And then we have the ordered pairs x comma f of x, minus 3 comma 9, minus 2 comma 4, etc. And so this one goes to the origin, 0, 0, and then 1 comma 1, 2 comma 4, and 3 comma 9. And when we plot these ordered pairs, it looks like this. So here we have the horizontal x-axis, and the vertical y-axis, and here are the various points that we computed the ordered pairs of. 0, 0, 1, comma 1, 2, comma 4, etc. And then the other branch goes up this way. And then this is the vertex also, the lowest point in this case, because it's upward opening. And so by contrast, if we have a graph of a function that looks like this, then we have a maximum for a downward opening parabola. Now, we also want to look at the effect of the factor a, the coefficient of x squared. And so the following graph gives us a very good overview of this. So we're going to look at three different graphs. One of them is f of x equals x squared. That's the one we just analyzed in detail with the ordered pairs, and we graphed that one. Now, when a equals 2, in other words, h of x equals 2x squared, then we notice that the function rises more rapidly. In other words, it makes it narrower. And of course, if a would be greater than 2, like 10 or so, it would rise even faster. In other words, it would be narrower. So, on the other hand, if a is less than 1, like 1/2, the graph tends to flatten out a little bit more, especially at the bottom, and it doesn't rise nearly as quickly as when the coefficient is equal to 2. So here the coefficient a is 1/2. So that's just something to keep in mind when you graph these functions and the effect that a has. Again, the sign of a matters too, and that is when a is positive, it's upward opening. And on the other hand, when a is negative, like in this case here, k of x equals minus 1/2 x squared, then the graph opens downward. So in other words, g of x equals 1/2 x squared, and k of x equals minus 1/2 x squared are identical, except this one is now flipped over the x-axis. The shape is the same. Here are some general comments about the graphs of f of x equals ax squared. The graph of f of x equals ax squared, or y equals ax squared, is a parabola with x equals 0 as its line of symmetry, and its vertex is the origin. For a greater than 0, the parabola opens up. For a less than 0, the parabola opens down. Also, if the absolute value of a is greater than 1, the parabola is narrower than y equals x squared. And when the absolute value of a is between 0 and 1, the parabola is wider than y equals x squared. So we will be looking at several examples of this. And the first one is graphing f of x equals minus 1/3 x to the second power. So when we look at this expression here, we notice it's a negative, so it's a downward opening parabola. And because the absolute value of a is between 0 and 1, the parabola will be wider than y equals x squared. So that's one thing we can see right away. To graph this parabola, let's make a table of values for x and then compute the corresponding function value. So this is for x, this is for f of x, and this would be the ordered pair x comma f of x. So let's say x equals 0, then f of x is 0, and this of course would be the origin. And when x equals -3, then f of x equals -3 as well. And so it's -3, 3. And when x equals 3, then f of x equals -3. This would give us a point 3, -3. And when x equals -1.73, then f of x equals -1. So we have -1.73, -1. And when x equals 1.73, then f of x equals -1, which gives us 1.73, -1. So now when we plot these points on the xy coordinate system, this would be our first point, and -3 -3. So it would be about here. And 3 and -3 would be the point here. And -1.73 is here, and -1 is over here. So that would be about here, and on the other side as well. So then when we graph the parabola, it'll look about like this. This is f of x equals -1/3 x to the second power. For the next exercise, we make a table of values as well for x and f of x and the ordered pair x comma f of x. So when x equals 0, then f of x is 0, which gives us the origin, 0, 0. When x equals 1, then 1 squared equals 1 times 3 is 3, which gives us a point 1, 3. When x equals -1, -1 squared is 1, and 1 times 3 is 3, and so we have the point -1, 3. When x equals 2, then 2 squared equals 4, and 4 times 3 is 12. We have the point 2, 12. And when x equals -2, -2 squared is 4, times 3 is 12. So we have the point -2, 12. Then we plot the points and connect them with a smooth line as well as possible. And this is the result. So this then is f of x equals 3x to the second power. So as in the previous exercises, we make a table of values for x and f of x and the ordered pairs x comma f of x. So when x equals 0, then the function is 0. So this is the origin, of course, and that's where the vertex is. And since a is minus 2, it's a downward opening parabola. So when x equals 1, then f of x equals minus 2. When x equals minus 1, since minus 1 squared is equal to 1 times minus 2, it's minus 2. And when x is equal to 2, 2 squared is 4, and 4 times minus 2 is minus 8. Similarly, when x is minus 2 squared is 4, times minus 2 is minus 8, which gives us the additional ordered pairs 1 comma negative 2, and minus 1 comma minus 2, and 2 comma minus 8, and minus 2 comma minus 8. So then we plot these ordered pairs and connect them with a smooth line. So here are the 5 points, the origin, minus 1 comma minus 2, 1 comma minus 2, minus 2 comma minus 8, and 2 comma minus 8. And now we're going to connect all these points with a smooth line. Here's the vertex at 0, and then the y-axis, x equals 0, is the line of symmetry. So in summary, then we have for exercise 1, we have the vertex at 0, 0, and the y-axis is a line of symmetry. And for number 2, we have the vertex at 0, 0 at the origin, and then the y-axis is a line of symmetry. And for exercise 3, we had the vertex at the origin, 0, 0, and the y-axis is a line of symmetry, which we can also write x equals 0. That would be the same thing as the y-axis. The second objective is graphs of f of x equals a times x minus h quantity squared. And so the graph of f of x equals a times x minus h quantity squared has the same shape as the graph of y equals ax squared. So if h is positive, the graph of y equals ax squared is shifted h units to the right. If h is negative, the graph of y equals ax squared is shifted absolute value h units to the left. The vertex is at h comma 0, and the line of symmetry is x equals h. So let's graph g of x equals x plus 2 quantity squared. To graph this function, let's make a table of values. And so we have some values for x. When x equals minus 2, then minus 2 plus 2 is 0. So g of x equals 0 at this point. And minus 1, x equals minus 1, then the function value is 1 squared, or 1. When x equals 0, then this term is 0, so 2 squared is 4, so 0, 4 would be the point. And when x equals 1, 1 plus 2 is 3, and 3 squared is 9. When x equals minus 3, then minus 3 plus 2 is minus 1 squared, and minus 1 squared is 1. And when x is equal to minus 4, then minus 4 plus 2 is minus 2, and minus 2 squared is 4. And when x is equal to 5, then minus 5 plus 3 is plus 2 is minus 3, and minus 3 squared is 9. So we have these ordered pairs, and when we plot these points in the xy coordinate system, it looks like this. So here we have here we have plotted the various points, and now we connect them with a smooth curve. Here's a vertex at minus 2, 0. And here's the line of symmetry, x equals -2. It's this vertical line. For exercise number 5, to find and label the vertex in the line of symmetry and graphing this function, let's begin by making a table of values. So here we selected some values for x. So when x equals 0, then we have -4 squared, which is 16, divided by 2 is 8. So we have the point 0, 8, the vertex. And then when x equals 4, 4 minus 4 is 0, so the function is equal to 0 at this point, at 4, 0. And, well, here's the vertex. And this is the y-intercept. And then when x equals 6, 6 minus 4 is 2, 2 squared is 4, 4 divided by 2 is 2. And when x equals 2, 2 minus 4 is -2, -2 squared is 4, divided by 2 is equal to 2. And when x equals 8, then 8 minus 4 is 16. 8 minus 4 is 4. 4 squared is 16. Divided by 2 is 8. So we have the point 8, 8. So now we're going to plot all these points. So here we have here we have plotted the points. So 4, 0 is our vertex. That's the point here. That's the vertex. And this is x equals 4 is the line of symmetry. Line of symmetry. And this is our function f of x. Number 6 is exactly the same function, except has a minus in front. So in other words, a downward opening parabola. But other than that, it's the same function as the one exercise number 5. So the graph of this function would just be flipped over the x-axis. And they look like this. So in other words, the graphs of these two functions are mirror images about the x-axis. The third objective for this section is the graph of f of x equals a times x minus h quantity squared plus k. And so the graph of that has the same shape as the graph of y equals a times x minus h quantity squared. But for a positive h, the graph of a times x minus h quantity squared is shifted k units up. And if k is negative, the graph of y equals a times x minus h quantity squared is shifted k units down, absolute value k units down. And here's the interesting thing. The vertex is the ordered pair h, k. And the line of symmetry is equal to x equals h, as we had before in the previous examples. And when a is greater than 0, k is a minimum function value. And for a less than 0, k is the maximum function value. In other words, once we have an equation written in this form, it gives us plenty of information about the vertex and the maximum and the minimum value, which is really of great interest in many of the applications. So phrased differently, note that if a parabola opens up where a is greater than 0, the function value or y value at the vertex is a least or minimum value. That is, it is less than the y value at any other point on the graph. On the other hand, if the parabola opens down when a is less than 0, the function value at the vertex is the greatest or maximum value. So here we have an upward opening parabola, and so the vertex is at a minimum, where k itself is the minimum function value. Here we have a downward opening parabola, and so here k is the maximum value of the function, where h comma k is are the coordinates of the vertex. So this is basically a graphical representation of what was discussed on the previous page in a more abstract way. These are good examples to keep in mind when you're dealing with any of these exercises. Let's look at number 7. We are to graph the function g of x equals x minus 1 quantity squared minus 3 and find the minimum function value. So here's the function. Here's a function, and here are some values for x. So when x equals 1, then x1 minus 1 is 0, and then the function value is equal to minus 3. When x equals 2, 2 minus 1 is 1, 1 squared is 1, and 1 minus 3 is minus 2. And when x equals 3, 3 minus 1 is 2, 2 squared is 4, and 4 minus 3 is 1. And when x equals 4, 4 minus 1 is 3, 3 squared is 9, minus 3 is 6. And when x equals 0, then minus 1 squared is 1, minus 3 is negative 2. When x equals minus 1, then minus 1 is minus 2, minus 2 squared is 4, 4 minus 3 is 1. And when x equals minus 2, we have minus 2 minus 1 is minus 3 squared is 9, and 9 minus 3 is 6. So we have these ordered pairs, and the vertex is 1 comma minus 3, h comma k, and the line of symmetry is equal to x equals 1. And the minimum function value is the value of k, so it's minus 3. So let's plot these ordered pairs and graph the function. So here we plotted the ordered pairs and drew the line of symmetry, and now we can connect the points with a line, and that'll be our graph. So here gives a graph of g of x equals x minus 1 quantity squared minus 3. For number 8, we are supposed to find the graph. To graph the function, find the vertex, the line of symmetry, and the maximum or minimum value. And since this is a positive value for a, we know it's an upward opening parabola, so we're looking for a minimum y value. Let's create a table of values for x, and then f of x, and the ordered pairs x comma f of x. So when we substitute for x the number 0, then we have 2 squared is 4, divided by 2 is 2, and 2 minus 4 is negative 2, which gives us the ordered pair 0 comma minus 2. And in a similar way, we compute the function values for a given value of x. For example, if x equals 2, we have 2 plus 2 is 4. 4 squared is 16, divided by 2 is 8, and 8 minus 4 is 4. So if the ordered pair 2 comma 4, etc. This is the vertex. So the minimum function value is, the y value is negative 4. And these are the coordinates of the vertex. Now we will plot these individual points on the xy coordinate system. Here are the various points plotted in the xy coordinate system as well as the line of symmetry. We noted the vertex at minus 2 comma minus 4. And now we can connect the points on the graph with a smooth line for the function graph. So here's a complete graph, with the vertex, the line of symmetry, the description of the function, and the minimum y value at -4. Exercise 9 asks us to find the same things, graph the function, find the vertex, and the line of symmetry, and the maximum or minimum value. And since a is negative, we know we have a downward opening parabola. That means we are looking for a maximum value of the function. And so first, let's generate a table of values for the ordered pairs. So in this case, h comma k, h is equal to -5, that's about equal to 5, and k is equal to 3. So 5 comma 3 is our vertex. So we know that as one point, and when we substitute the values for x, like 4, into this equation, f of 4 is equal to 1, f of 6 is equal to 1, f of 3 is equal to -5, and f of 7 is -5 also. So we have these ordered pairs. We will plot them, and the line of symmetry goes through the vertex, the line of symmetry is the equation x equals 5, and the maximum value is 3, given by the value for k. Maximum value of the function is 3. Here are the plotted points, the ordered pairs, which we'll now connect with a smooth line to graph the function f of x. Here's a completed exercise with a graph of the function, the vertex, the line of symmetry, and the maximum value of 3. And this concludes section 7.5.